Hello and welcome. Let me introduce myself. My name is Joko Ontoroswarno from Sanata Dharma University, Indonesia. I will present a paper titled A Visual Approximation of Fourier Transform Operations using GeoGebra, presented at the International Conference on Mathematics and Learning Research, Commerce 2022, with terms enhanced mathematical and computational thinking in digital technology era.
The agenda for this presentation is Introductions, Fourier Transforms, GeoGebra, Results and Discussion, Conclusion, Acknowledgements. Fourier transform operations involve the multiplication of complex exponentials and infinite integrals. Students often have difficulty understanding the operations that occur in the Fourier transformation. The exponential multiplication operation looks complicated. Many books describe the Fourier transform to save transform operations into a fast Fourier transform. Students learn more about algorithms than transformation operations. Advances in technology and software. Computing does not pay attention to the simplification of complex multiplication, but the speed of computing. GeoGebra is a tool for learning and mathematical visualization. Easy to use, so users don't need operating savings in computing. Fourier transformation is shown in the following equation. Continuous Fourier transformation and discrete Fourier transformation. Xt is the time domain signal, and xf is the result of the Fourier transform in the frequency domain. Converting the time domain signal into a data series is done by multiplying the time domain signal xt with the impulse function series delta t minus nt. The following slide shows the location of the points on the complex exponential. The result is a polar form. The more points there are in the exponential, the more closely they form a circle. The dots on the negative complex exponential with a range of 0 to 2 pi produce clockwise rotation direction in the polar form, while the positive complex exponential produces counterclockwise rotation direction. Fourier transform operations consist of mapping operations on polar form or complex exponential multiplication with time domain data x, n, and sum or integral product of xn, multiplication with complex exponentials. Fourier transformation test. Number 1. Test with a single frequency sine function. Number 2. Test with a two-frequency sine function. Number 3. Testing with pulse function.
Map the sine function into a polar form with a frequency from 0 to 12 radians per second. Consider the integral in polar form, where the highest value center of mass occurs at sine at frequency 1 radian per second. For other frequencies, the result of the sum of the dots in the polar form will produce a value of 0. Map the cosine function into a polar form with a frequency from 0 to 12 radians per second, in linear increments. Notice the point of the center of mass is always changing for each frequency value. Frequency response as a mapping of the calculation of the center of mass shows that the maximum peak is at the resonant frequency of the sine wave at frequency 1 radian per second. For other frequencies produced small wave ripples. The response frequency for the cosine with frequency 2 radians per second signal indicates that the peak response is at a frequency of 2 radians per second. The frequency response results show symmetry for the negative and positive frequencies. The frequency response results show symmetry for the negative and positive frequencies.
The frequency response for the cosine 2t plus 1/2 cos 4t signal indicates the peak response is at a frequency of 2 radians per second and 4 radians per second with an amplitude of half. radians per second with an amplitude of half. The frequency response for the pulse signal produces the sin function. The narrower the pulse signal will produce a wide sin response. On the other hand, the wider the pulse signal, the wider the sin function will be. My conclusions: Fourier transform can be done using GeoGebra. Visualization can be done for small data and can change the display speed. Through visualization using GeoGebra, students are expected to be able to understand the operation of the Fourier transform. Thank you for attending this presentation.